Hi, I'm Venkat Lakshmi Kottapalli. My CW ID is 50369283. My topic is on ThreadX Microsoft Express Logic. So let's see the overview of ThreadX Microsoft Express Logic. So overview of ThreadX. ThreadX is an embedded real-time operating system known for its efficiency and scalability. Initially, it was developed by Express Logic and now it's a part of Microsoft offerings. ThreadX provides a robust framework for multitasking and real-time operations. ThreadX has key features that include small footprint, fast content switching, deterministic behavior, and scalability. Let's see the history of ThreadX. So, the ThreadX was introduced in the year 1997, and later by the passing years, ThreadX has introduced many series. In that, the ThreadX 4 and ThreadX 5 was introduced in 2001 and 2005. And for the ThreadX, there are embedded file systems that includes FileX, NetX, USBX that are introduced in 1999, 2002, and 2004. ThreadX SMP for SMP multi-core environments was introduced in 2009. In 2011, ThreadX introduced ThreadX modules, and in 2014, ThreadX achieved a safety certifications for TUV IEC 61508 in 2013 and UL 60730 in 2014. And in the same year, ThreadX introduced GUIX embedded UI for ThreadX, and later the ThreadX was purchased by Microsoft on April 18th, 2019. Let's see the architecture of ThreadX. So the modular architecture of ThreadX enables flexibility, scalability, and user friendliness in embedded systems. It is composed of a series of user level services that are constructed on the top of the kernel, which provides the essential functions for handling interrupts, memory allocation, synchronization, and thread management. So the first architecture of ThreadX is core kernel. So the core kernel is in charge of overseeing the RTOS essential functions such as interrupt handling, memory management, task scheduling, and synchronization. The fundamental components required to create a real-time embedded system are provided by kernel. And in for the core kernel, there are important elements that are block of task control, scheduler, synchronization primitives, memory management, and handling interruptions. So these are the important elements of co-kernel. And let's see the next architecture of ThreadX, that is middleware components. To increase the capability of co-kernel, ThreadX provides a variety of middleware components that can be integrated with it. So the FileX, NetX, USBX, and GUIX are the example of middleware components. And the next architecture of ThreadX is hardware abstraction layer. The hardware abstraction layer is optional layer, but it helps the developers to construct portable programs that work with a variety of microcontroller and microprocessor architectures by abstracting the underlying hardware. The hardware abstraction layer guarantees that the middleware and core kernel can operate successfully on the target hardware and makes it easier to adapt ThreadX to different hardware platforms. And the last architecture of ThreadX is application layer. The user's application code is located at the application layer. The ThreadX API is used by developers to manage resources, generate tasks, and communicate with middleware components. This is about the architecture of ThreadX. Let's see the features of ThreadX. So the popular real-time operating system was created for ThreadX because of its small memory footprint, quick execution, and user friendliness. It is a great option for developers working on real-time applications because of its many features that includes primitive multitasking. So ThreadX facilitates primitive multitasking, which enables smooth transitions between many activities that are running simultaneously. And the next is priority based scheduling. So ThreadX manages tasks through the use of priority-based scheduling mechanism. Every task is given a priority level and the scheduler makes that the tasks with higher priorities are completed before those with lower priorities. And the next feature is quick content switching. So ThreadX design reduces switching overhead and improves system efficiency by enabling rapid content switching between tasks. And next is small footprint. ThreadX is appropriate for embedded systems with limited memory because of its small memory footprint, which usually ranges from 2 KB to 10 KB. And the next feature is deterministic behavior. For real time applications where consistent and predictable behavior is required, ThreadX deterministic reaction times are crucial. And the next is easy to use API. With ThreadX user friendly API, developers can create and manage tasks, timers, queues, and other systems resources more easily, which streamlines application development. And the last feature of ThreadX is safety critical certifications. This include ThreadX is dependable option for safety critical applications since it has been certified to a number of safety critical standards including ISO 26262 ASLD, DO178C DALA, and IEC 61508 SIL4. And let's see the applications of ThreadX. So there are many applications of ThreadX that are consumer electronics like smartwatches, fitness trackers, and audio devices, and automotive systems that are advanced driver assistance systems, infotainment systems, and vehicle networking and communication systems. And another application is industrial automation. So this involves programmable logic and controls, human machine interfaces, and robotics and automation systems. And another is aerospace and defense. So it includes advanced systems, flight control systems, guidance, navigation, and control systems. And the next application is medical devices. This includes patient monitoring systems, drug delivery systems, and infusion pumps, medical imaging devices like MRI, CT, and ultrasound. And the application of another application of ThreadX is IoT devices. This includes edge computing devices, smart city infrastructure, and gateways. And the last is networking and telecommunication. This involves network routers and switches, wireless access points and base stations, and network security applications. These are the applications of ThreadX. And next is advantages and disadvantages of ThreadX. So the advantages are real-time performance, small footprint, modularity, safety and security, board hardware support, and active development and support. And the disadvantages are licensing and cost, limited support for open source software, less customization, and vendor lock-in. So these are the advantages and disadvantages of ThreadX. Let's see the organizations that are currently operating in this market. Since Microsoft acquired Express Logic, it is currently the main company in charge of ThreadX. Before the acquisition, Express Logic developed and maintained ThreadX and was well known for its proficiency with real-time operating systems for embedded systems. But now, Microsoft is the only organization that is operating ThreadX. And ThreadX is now incorporated into Microsoft Azure IoT offering following its acquisition. And next, let's see the future outcome and conclusion. So, the future outcome of ThreadX is enhanced real time capabilities. By ensuring highly responsive performance for embedded systems, ThreadX is expected to continue improving its real time capabilities. And the next future outcome is advanced resource management. The OS will likely offer better resource management tools, optimizing system resources for efficiency and reliability. And the next future outcome is seamless IoT integration. So this means ThreadX will further integrate with IoT technologies, enabling seamless connectivity and communication in IoT ecosystems. And the next future outcome is artificial intelligence and machine learning support. So the OS is anticipated to provide enhanced support for advanced artificial intelligence and machine learning applications, empowering developers to create intelligent embedded systems. And the next future outcome is scalability and time to market. So ThreadX will enable the creation of scalable solutions with reduced time to market, supporting the rapid development of embedded solutions across various industries. So these are the future outcomes we can expect from ThreadX Microsoft Express Logic. And let me conclude this PPT. So, in conclusion, ThreadX evolution under Microsoft stewardship promises a future where embedded systems benefit from enhanced real time capabilities, improved resource management, seamless IoT integration, support for advanced AI and machine learning, adherence to functional safety regulations, energy efficiency optimizations, and a robust development ecosystem. These advancements position ThreadX as a leading choice for developers seeking to build intelligent, secure, and energy efficient embedded solutions for diverse industrial applications. So, this is all about ThreadX Microsoft Express Logic. Thank you.